Hi my friends, welcome to the group Living with Math. This time I'm going to do this video in English. So I'm going to solve the problem I put in the group. So let us say that I have a sequence, let us say x index n, in which x index 1 it's equals 1 and x index n plus 1 it's equals to square root of x index n minus 1 over 4. And I want to show you that this sequence converges, and also I want to calculate the limit. So to make the solution of this question, I'm going first of all to apply to a nice math result. Let us say that the limit of x index n when n approaches plus infinite, let us say that it's equals to x. Okay, so here it is the nice result that I'm going only to speak about it, but I'm not going to demonstrate it. Okay, let us go to in a nice way to accept this part. Okay, so the limit of x index n plus 1 it's also equals to x. So let's agree in this context. So if it is like this, the limit of our sequence, it will be limit of x index n plus 1 equals to the limit of a square root. But the limit of a square root is the square root of the limit. So I can write down a square root of limit of x index n minus 1 of 4. So if I take this limit as x, it is easy to understand that I will have x equals square root of x minus 1 over 4. And so I have here an irrational equation, and I'm going to solve it. It is very simple to solve. So it is very, very simple to understand that I will have x plus 1 over 4 equals square root of x. And now I'm going to square. So x plus 1 over 4 squared, it's equals x. And now I'm going to develop this expression. So I will have x squared plus 1 half of x plus 1 over 16 equals x, which is the same as to say x squared minus, because I can jump, let us say like this, with this x to the first member, and so I will have minus 1 over 2x plus 1 over 16 equals 0. I think that it is not very difficult to understand that this is the same as to have x minus 1 over 4 squared equals 0. If I develop the expression, I will have x squared minus 2 times 1 over 4 plus 1 over 16. And so the solution, it will be x equals 1 over 4. Okay, that's nice. And so if there is limit, it must be 1 over 4. So now, to show you that this is in fact the limit, I must apply to another theorem. If this sequence, let us say x of n, is greater than 1 over 4, and I want mean with this that the sequence is bounded below, and also if the sequence is all time decreasing. I want to mean with this that x index n plus 1 is lesser than x index n, so I can say that the limit exists, and if the limit exists, it must be x equals 1 over 4. Okay, so I must prove first of all this part of my way, and then I will prove another part of my way. And if I prove these two sentences, so I can say that the limit exists, and if the limit exists, it must be x equals 1 over 4. Okay, I'm going to make this proof. I want to say this proof over here and this proof over here. I'm going to make this by induction in the set of the natural numbers. So for the first one, I must see about x index 1, and x index 1 it's equals 1. The text tells us about that. Okay, it is here written. So 1, of course, it is greater than 1 over 4. Now I must look to my hypothesis, and so we are going to agree that our sequence, let us x index n is greater than 1 over 4, and I want to show you that this implies that x index n plus 1 is greater than 1 over 4. So if it is the case, let us put an I in this part of our implication in this inequality. Let's put an I over here, and as you can see, x index n plus 1 is the same as to have square root of x index n minus 1 over 4. Okay, that's good, because now I can begin in my hypothesis and I can grow, and I will get easily this result. So if I have this, also it is true that square root of x index n is greater than square root of 1 over 4. Or it is the same as to say that square root of x index n is greater than 1 over 2. It is all time I am arriving at the end, and now I must sum to the sides of this inequality the value minus 1 over 4, and I will have square root of x index n minus 1 over 4 greater than 1/2 minus 1 over 4. And this part over here, it is of course x index n plus 1, which is greater, it is a simple calculation I think, greater than 1 over 4. Okay, so I did prove by induction in the set of the naturals that this first step. So let's go to the second step. So let's take n equals 1, and let us show that x index 2 is lesser than x index 1. So I receive the message, I go to stop a little bit, and then I continue. Okay, now I did read the message, so now I'm going to continue. So x index 2, it is the same as to have square root of x index 1 minus 1 over 4, and I want to show to you that is lesser than x index 1. But x index 1 is equals 1, okay? So this means that 1 minus 1 over 4, that's lesser than 1. And this is true, of course, because minus 1 over 4 is lesser than 0. Okay, let's go now to our hypothesis, and we must agree that x index n plus 1 is lesser than x index n, and I'm going to show to you that this implies that x index n plus 2 is lesser than x index n plus 1. Okay, so again, because it is a nice way to have an idea how to come in how to walk in this in the problem. Let's put an eye in this part of the inequality, which is the same as to have the square root of x index n minus 1 over 4 lesser than, I'm sorry, here it is n x index n plus 1, okay, minus 1 over 4 lesser than square root of x index n minus 1 over 4. Okay, now I can grow, because I'm going to take here the square root. Okay, if this is lesser than this part over here, so I can write down that square root of x index n plus 1 is lesser than square root of x index n. And now I must sum to the both sides of this inequality the value minus 1 over 4, and I will get square root of x index n plus 1 minus 1 over 4 is lesser than square root of x index n minus 1 over 4. And so finally I came to the end, because this is x index n plus 2, which is lesser than x index n plus 1. So I did prove that our sequence it is bounded below, okay, and it is of time decreasing, so there is limit, and if there is limit, the limit must be x equals 1 over 4. Okay, so for now it is done. Maybe I will come today, I don't know, but I want to wish you a very nice day. Bye bye, my friends.